Okay, good day, good people. Let us continue with our kinematic. I believe that you went through the given notes on your kinematic. We said it that kinematic, it basically deals with your motion. Yeah. Then motion, it's a change of position from point A to point B. Now, in short, in our kinematic, like I said on those notes, that we'll be determining the vector. Now, whenever you change position from point A to point B, there's a starting point and the end point. You are in a specific direction. That means motion, it's a vector. Now, we will be dealing with two things. Vector is a quantity that has magnitude and direction. Vector, it's a quantity that has two things, magnitude and direction. Before we can get to the how part of calculating the vector, the magnitude and direction, let us first start with the naming of direction. Now, it is easy to use the 4 cardinal points of the compass to indicate the direction. Or rather, we'll be using the naming of direction using the 4 cardinal points of a compass. What are the 4 cardinal points of a compass? It is north, east, west, and south. It is north, east, south, right, and west. Those are the 4 cardinal points of a compass that we'll be using to name what? To name direction of what? Of a vector in your kinematics. That's what we'll be dealing with, good people. Right. Please, we know that our cardinal points, they are, or rather the direction indicated in a quadrant. This is your quadrant. This is your quadrant. You know, your Cartesian plate, your quadrant. We know that east, it is at 0 degrees when we are using your quadrant. Then north, it is at 90 degrees. West, it is at 180 degrees. Then 270. South, it is at 270 degrees. Then the cycle, it is completed east, it is at 360 degrees. That we know. We know that the first, if we were to use the quadrant or your Cartesian plate, we know that all signs are positive on the first quad. Now on the first quad, we are having 0 plus or 90 minus. That we know. Then the second quad, it is made up of 90 plus or 180 minus. 180 minus. Then the third quad, it is 180 plus or 270 minus. Then a minus. Then the fourth quad and the last quad, it is 270 plus or 360 minus. All this quad, they are made up of what? Of 90. All this quad, they are made up of what? Of 90. All of them. All this quad, they are made up of 90. 90. 90. They are made up of 90, all this quad. 90 minus 0, it is 90. 180 minus 90, it is 90. 270 minus 180, it is 90. 360 minus 90. 360 minus 270, it is 90. The quad, it is made up of what? Of 90. Having said that means when you are having a direction on your northeast, if you are having a northeast direction, northeast direction, that means it is what? It is 9. You are on the 45-degree angle. You are on the 45-degree angle. Why? Since all the quads are made up of 90, and northeast, it seems as if it is the half of this quad. Since all that quad, it is made up of 90, it will be 90 divided by 2. 90 divided by 2, it will give you what? It will give you 45. But we check, you are on which coordinates? You are on north and east. That is why your northeast, it's what? The northeast direction, it's what? You are on the 45-degree angle. Same thing here, the fact that they are made up of what? Of quads. Now you are having a southeast. Southeast, it's a 45-degree. It's a 45-degree direction or angle. Now, southwest, you are on the 45-degree as well. Southwest, you are on the 45-degree angle. Right. Now, northwest as well. Northwest, you are on the 45-degree angle. 45-degree angle. Right. Now, when given a direction and they said you are moving on northeast, you know that you are at the 45-degree angle. Whenever you depict the direction, you would tabulate it. You would say, this is my north, this is my east, this is my south, this is my west. And they are saying you are heading towards northeast. You know that you are on the 45-degree angle. This is where you are traveling. From north to where the magnitude is, it is 45 degrees. From there to there, it is 45. From there to there, it is 45. You know that you are on the 45-degree. And we will be using this Cartesian plate to name our direction. Now, if you are given, if you are given the statement, here, the wiping is taking forever. I'm using the whiteboard, you can tell. Right. We're using the whiteboard-ish. Right. Let's say you are given a vector and you are somewhere here, and you are told that that angle there, it is 20 degrees. All right. Now, if you are naming such a vector on that direction, remember we are dealing with the naming of direction. You want to say east. If you are naming it, you want to say east 20 degrees north. Right, this is how you will name it. Let's say you are having a vector here. The angle here, it is 10 degrees. The angle there, it is 10 degrees. When you are naming the direction for that, it will be south, 10 degrees, east. Now, the principle here on these two examples, it is based on this principle. Yeah? It is based on this principle. It is based on this principle. Right. And name the cardinal closest to the vector, closest to the force vector or force first. Yeah. Then the angle of deviation. Towards the now, that which I did, it is based on this principle here. It is based on this principle here. Right. Name the cardinal closest to the vector or force first. Now, going back to this example here, the cardinal, this is where the four cardinals are. Your north, east, west, south. That's where the cardinal are. Now, the principle here says name the cardinal closest to the vector first. Now, coming to this one, you can tell that this vector or force, it is close to what? To east. Can you see that? It is close to what? To east, because your quad, it is made up of what? Of 90. 90 minus 20, that means from here to there, it is what? It is 70. The angle of deviation, it is 70 there. Now you can tell that for me to go to north, if I were to make this kilometers, from where the force is to where north is, I have to travel 70 kilometers. It is far from me. But the one that it is close to this force, it is east. Because from where the force is to east, if this is 20 kilometers, you can tell that the distance between here to there and between here to here, the shortest one, it is from this one to east. Now, that is why the principle says you start with the cardinal. The cardinal closest to the vector or force. Now, the force, it is close to east. You start with east as your reference point. The angle of deviation. East, 20 degrees what? North. East, 20 degrees what? North. The other, then it says then the angle of deviation towards the other cardinal. And towards other cardinal, it will be what? North. Because everything is occurring on what? On the first quad. Now, including the second example as well. The cardinal which is close to this vector, it is what? It is south. Now, hence, south would be your reference point. You are having south 10 degrees, then the other angle of what? Of deviation. That's how you will name your direction when coming to your vector. It is based on this principle here. It is based on this principle, the naming of what? Of direction. Let us wipe so that you can see clearly there. Right. The naming of direction, it is based on this principle here. It is based on this principle, good people. Please jot it down. It is based on this principle. Right. The naming of direction when coming to your kinematic, it is based on this principle. It is based on this principle. Please make note of it. As I made the example here, it is based on the naming of direction. Now, we will look at how to calculate the magnitude and how to calculate the direction. On this one, I was just dealing with what? With the naming of direction when coming to kinematic. Thank you, good people.